How are you, my friends? In this video, I'm presenting the first 10 out of the 30 old exams review questions for the algebra course, lectures 24 to 30. We start from other types of equations until the linear functions. Now let's see, question number 1. We need the sum of all the solutions of this equation. I think you have tried this, and we have a multiple choice, A, B, C, D, E. Let's see. This equation, we have to rearrange it, and then it is quadratic in form. So bring the 12 on the other side, becomes minus 12. Let n, don't expand here, please. You make it a little more complicated. Let n is 2 minus square root of x minus 1. So this one is the squared. It will be n squared there when you square both sides. So now you have n squared minus n minus 12 is equal to 0. Easy to factor. N minus 4, n plus 3. So n will be 4 or n will be minus 3. Now be careful here. There is a little trick. Now 2 minus square root of x minus 1. This is n is equal to 4. Right? Take this on this side, it will be minus 2. See, this is a positive number, cannot be equal to negative number. So that's rejected. Now, suppose you did not pay attention. You square both sides here. X minus 1 is equal to 4. And then you have to check. Again, it will be rejected. Now this one, put 2 minus square root of x minus 1, which is the n here, is equal to minus 3. Rearrange it, it will be square root of x minus 1 is equal to 5. Square it, both sides. X minus 1 is equal to 25, so x will be 26. You have to check also. 26 is okay if you replace it in the equation here. So the solution set is 26, and the sum is 26. The answer is E. Question number 2, solve the inequality. We have a compound here. Compound means two inequalities, and we have absolute value of 10 minus x inside the absolute value here. So first we have to remove the 3. We have to rearrange it. So you add the 3 on each side. Add 3 there, it will be 0 here. Add 3 there, it will be 4. Add 3 there, it will be 12. So now we have this yellow absolute value between two numbers 4 and 12. We have to split it. So we say 4 less than or equal to absolute value. Intersection, we find the solution there. Intersection, the absolute value less than 12. See, I put everything here in details. So you have to split it and solve each one. This one, case number 3, you can see all the ideas and the formulas in lecture 26. Case number 3, absolute value greater than, this is case number 3 here, by the way. Absolute value of x greater than c. So we have to say x minus 10 less than or equal to minus 4, or x minus 10 greater than or equal to 4. You solve each one. This is a linear, so no need for table of signs. So this is minus infinity to 6, union 14 to infinity closed. Now this one here, absolute value less than 12, also lecture 26. So this is case 2. Case 2, I wrote it there. Absolute value of x less than c, x between minus c and c. So this is a linear compound. No need to split. So add 10, add 10, add 10. Open from minus 2 to 22. Now you have to graph it here, a little nice graph. From minus infinity to 6, and then until 14 here to infinity. The other one is open and open between minus 2 and 22. Take the intersection. So from minus 2 open until 6 closed, union, the other part 14 closed until 22 open. That's the answer for our question there. Please check this one. Number 3 is easy and fast. Which relation defines y as a function? You know, the function, every x in the domain should have exactly one y. So we see here half 0, half 1/4. So half is a number that has two images, not function. This is a circle. This is absolute value on the y, so it's a v-like to the right or to the left. And this one, x squared, y squared. Every x may have two y's. So the answer here clearly is C. Every x has only one y. See, you rearrange this. If you take any x, this will be 3y there. If you put any x, you get only one y. So that's a function. Now let's go to the inequality. 16x greater than or equal to x to the power 5. Now, one mistake students can do sometimes, they divide by x. You cannot do that here. Inequality, less than, greater than, all this inequality. You cannot divide by variable because the variable can be positive or negative. That's the reason. So we just rearrange it, move everything on one side. This is a nice question, by the way. Remove it here and then take a common factor. So we do the factoring x, and then 16 minus x power 4 will be 4 plus x squared, 4 minus x squared. We can factor again here, 2 minus x, 2 plus x. This one we leave it. Now look at the nice part here, 4 plus x squared, it's all positive. We leave it there, positive, positive, positive. Because x squared is positive, 4 is positive. X can be positive or negative. 2 minus x can be positive or negative. 2 plus x can be positive or negative. So we call this table of signs, lecture 25 in the algebra course. You can go and check all kind of examples and the rules. We choose here a number, and then we replace it in the x. Remember, we don't touch 4 plus x squared. Just put it in the table. You have to show it. It's all plus. So you take a number here, let's say minus 10. You replace it in the x. From here, you take minus 1. From 0 to 2, you take 1. From 2 to infinity, you take 5 or 7 or 9 or 10 or 12 or 50. Replace it in the x. Now, when you multiply, we go back to the question in the yellow here. We take greater than or equal to 0. So we choose the positive. See the positive here, from there to there, union from there to there. That's the answer. Minus infinity to minus 2, closed, union, close 0 to close 2. Question number 5 is a linear function. F is a linear function such that f of 5 is equal to minus 3, f of k is equal to k minus 1. Find k if the rate of change is 7. It's not difficult. Now we have a function linear, which is a straight line. F of 5 is equal to minus 3, so that means x here is the 5. You see that one? And y is minus 3, so that's a point. Another point, x here, k is the x. See, always the x is inside. The outside is 2k minus 1, that's y. So we have 2 points on the line. Find the slope. You see, slope will be y2 minus y1, the formula, over x2 minus x1, y2 minus y1 over k x2 minus x1. And we said the rate of change is 7, and the slope is the rate of change, actually, by definition. So that's 7 from the given. Now cross multiply, k will be 37 over 5. Now, question number 6 about greatest integer function. We have a function given there, and then f of x is equal to 6. That means the y value here. See, I replace f of x here by 6. What are the values of x that will give me the integer or the y or the n is equal to 6? So we replace here 6, then we start to solve this by a formula. We called it nice formula. You can see that in lecture 28. So replace there by 6. See, take 2 on the other side, becomes 4. Multiply by 3, so that's 12 now. See, now this is the greatest integer is equal to 12. 12 now is the n. See that? 12 is the n, not the 6. 6 was given. F of x is equal to 6. We need all the values of x. But to apply the formula, we have the greatest integer equals a number. That is the n, 12. So we take the expression, inside the expression here, half x minus 1, between closed n, that's the nice formula, less than n plus 1. So n is the 12 here. So I say 12 less than or equal to this, less than 12 plus 1. And then, you know, this is a compound inequality. So we add 1 there, and then we multiply by 2. It will be closed 26 to 28. The answer is D. You can see D is there here. 26 closed to 28 open. Rational inequality. Rational inequality, remember, we have to remove, like polynomial inequality, we have to remove all the terms on the left, and then you combine the terms on the left. Move all the terms and then combine it. So take 2 there, minus 2 now becomes greater than 0. Now we have to find, now to combine it. Combine it, see, x minus 1 squared. So you multiply up and down here by x minus 1 squared. See, we are adding rational expressions. So there should be minus 2 bracket x minus 1 squared here, up and down. Now we leave the fraction, remember, we don't get rid of the fraction here, we leave it. Now you have to expand this x minus 1 squared. You know the formula, x squared minus 2x plus 1. Multiply by minus 2 and then add everything. What do we get here? 3x squared minus 2x squared, that's x squared, minus 3x plus 4 is plus x, plus 2 minus 2 is 0. So now we have this one here. Look at this, nice. This one, the same as this one given, but simple, we have 0 on the right, then ready to make table of signs. Now from the last slide, we get x squared plus x over x minus 1 all squared greater than or equal to 0. We continue factoring up, down, it's already factored. Remember guys, it's already factored, leave it. So x plus 1, x minus 1 squared. Now we take all the zeros, 0, minus 1, and 1. We put that all on the table. Minus 1, 0, and 1. Remember x minus 1 squared? We have to put it on the table, all pluses. Now, in the other x and x plus 1, they change from pluses to minuses according to the number we choose. So we have, like, let's say minus 10 here. So that will be minus and minus. Between minus 1 and 0, I take minus half. So that's minus and plus. Between 0 and 1, I take half. And this is also greater than 1. So look at the table now. If you multiply and divide, you get plus here for the result. That's a minus, that's a plus, that's a plus. We need greater than or equal to 0. So I have to choose this one, that interval from minus infinity until minus 1, and then 0 to 1, and then 1 to infinity. Now, it should be all closed because we have greater than or equal. But remember, to remove all the zeros of the denominator, so 1 should be only open, at 1 open. Otherwise, we put it closed. Question number 8, we come back to a nice question where we have x minus 1 to the power 4. Here we have x minus 1 to the power 2. Power 2 here is half this power. So we can think of quadratic in form. Remember here, we need the number of real solutions, and then the sum, and then the product of all the solutions. So you add all the solutions, you multiply all the solutions, and the number of the real. So this is quadratic in form. So rearrange the equation here, and then let the smaller power, x minus 1 squared, all of it equals to n. You can choose y or any letter you like. So this will be 4n squared plus 15n minus 25 is equal to 0. This is a quadratic, and this one quadratic in form. Quadratic in form is in lecture 24, guys, if you want to check it. So we factor here by slide and divide, or by trial and error. 4n minus 5n plus 5. Let's check it here. 4n squared, that's 20 minus 5 is 15, minus 25, it's okay. So n will be 5 over 4, or n will be minus 5. Remember, back to x. So I take n here, which is 5 over 4, x minus 1 squared. Take the square root here, so x minus 1 plus or minus square root of 5 over 4. Now just simplify it. This stays square root of 5, this square root of 4 is 2. Take one on the other side, find the LCD, so 2 plus or minus square root of 5 over 2. That's the two solutions from this. Or x minus 1 squared is equal minus 5. Take the square root, so x minus 1 plus or minus square root of minus 1. That's a complex number. So it will be square root of 5i. Two solutions complex, two solutions real. Maybe in another question, you can have all real 4. Sometimes you can have all of them 4 complex. It depends on the numbers. Now look at the nice answer here. The solution from the last slide, 4 solutions here. 4 solutions, you see, 2 real, 2 complex. Now let's answer part A. Find the number of real solution, 2. This is real, irrational. Find the sum, you add all the solutions. See, it happened, it's 4. See, when you add them, this will be cancelled. Here you add, this will be cancelled. 4 over 2 is 2, so the sum is 4. Now the product is more difficult. You have to multiply conjugates here, multiply the conjugates. Okay, and then multiply the conjugates by any way you like. You will get minus 3 over 2 is the final product. You can check it, please. Number 9, given the equation of a circle. Now we come back to the circle. Find the domain and range. So circle, guys, is lecture 20. If you want to go and review, completing the square, you have to complete the square. On the x, complete the square on the y. You know, when you complete the square quickly here, this should be 1. Coefficient of y squared and x squared should be 1. If it is not 1, we make it 1. Now we take minus 8, divide by 2, 4, square it. 16 minus 16. I can add 16 here and 16 on the other side. And then I can add and subtract on the same side. That's the same. Now for y, minus 6, divide by 2, 3, square it, 9. I can add 9 and subtract 9 on one side here. Or I can add 9 there. It's the same. When you rearrange it, you get x minus 4 squared plus y minus 3 squared is equal to 4. So now we need the center for 3. So here's the center for 3. And the radius is 2. So that's the circle. Now the question, find the domain, the values of the x. The values of, if you press all this circle on the x-axis, you see it will cover from 2 to 6. That's the domain. If you press it, the whole circle on the y, it covers from 1 to 5. So that's the range. Or you can go to the center here for 3. See, h is 4. You see the 4 because on the x, h on the x. So you subtract r and then you add r on the right and left. That's the domain. Now for the range, you take the k on the y value, 3. You subtract r, you add r, which is r is 2 now in this case. Then you get 1 to 5. Question number 10, given the function, if the range is m to n, find the value m times n. That's a function. I think it's a parabola here because we have squared on the x, f of x always y, x between minus 1 close to 3 open. Just take some numbers from there and then graph the whole parabola limited to this condition. So that's a restriction. So the given here is a restricted domain from minus 1. So if I put minus 1 there, quickly you put minus 1, minus 2, square it, that's minus 6. You see minus 1 is minus 6, put it there. And then you can take other points until you reach 3. Take 3, guys. Now you might say x less than 3. Yes. Take 3 and put it open. Put 3 there, 3 minus 2, 1, square it. So that's 2, right? So 3, 2, you see 3, 2? It's open. So only we need the graph. See, this is parabola. If you complete it, it will be parabola here, complete parabola. But we have only restricted domain between minus 1 and 3. So now there's a point here at 2. See, if you put 2 here, the maximum value will be 3 there. So the range becomes closed from minus 6, you see, closed until closed here 3. Because this 2 is below that point 3. Now m and n will be minus 6 times 3 is minus 18. This is the first 10 questions out of the 30. You can see the other 2 videos. If you liked the video, thank you first. for watching. And if you like it, you can share it and subscribe. Well, I can see you in another video with another topic. Thank you very much for watching.